Hey everyone, today we are going to solve the Daily LeetCode challenge of 9th April 2024 and the problem statement is time needed to buy tickets. So let us first understand the problem statement. So according to the problem statement, we have been given an integer array tickets such that each of the value of this array represent the number of tickets the ith person wants to buy. So it means that the person at the 0th index wants to buy 2 tickets. Similarly, the person at the first index wants to buy 3 tickets. The person at the second index wants to buy 2 tickets. And similarly, the person at the third, fourth, and fifth index wants to buy 4, 6, and 1 tickets respectively. Correct? Now, according to the problem statement, all of these persons are standing in a queue. So what is a queue? A queue follows FIFO. Now, what is FIFO? FIFO means first in, first out. So a person who would be standing at the first of the queue would be given the opportunity to buy the ticket first, and similarly the person who would be standing at the end will buy the ticket at the end. Correct? Now, according to the problem statement, it has been mentioned that if these are the person, right? Let us consider 3 people as of now. Okay, so if these 3 people wants to buy tickets, correct? So how many tickets does this person wants to buy? This person wants to buy 2 tickets. Now it has been mentioned that at a time each person can buy only 1 ticket. Okay, only 1 ticket. Okay, so this person will buy 1 ticket, and it has been mentioned that in order to buy 1 ticket, it takes a time of 1 second. Correct? So how much time did this person took? This person took 1 second of time in order to buy a ticket. Correct? And since he had bought a ticket, so we will decrement the count of tickets that he wants. Correct? So now he wants only 1 ticket because he has already bought a ticket. Now, according to the problem statement, it has been mentioned that once this person buys a ticket and he still wants to buy a ticket, so what he have to do? He have to go at the end of the queue, correct, in order to buy all of his next tickets. So what this person will do is this person will go at the end of the queue. So it means that this person was the 0th person, this was the second person. So this 0th person will come over here and he still wants 1 ticket, correct? Let's remove this from here. So he'll come at the person standing at the first position. Now, how many tickets does this person wants? This person wants 3 tickets. But according to the problem statement, it has been mentioned that he can buy only 1 ticket at a time. So what we will do, we will allow him to buy 1 ticket. So he will be remaining with 2 tickets more to buy. And he will take a time of 1 second in order to buy that 1 ticket, correct? Now, since this person wants to buy some more tickets, so what we will do, we'll send this person at the end of the queue, correct? So it is the person at the first index who wants to buy 2 more tickets, correct? Let's remove this. Now we'll reach at this particular person. Now this person wants to buy 1 ticket. So we will let him buy 1 ticket. So he will be remaining with 0 ticket to buy. And he will take a time of 1 second in order to buy that 1 ticket, correct? Now, we can see that the number of tickets that this person wants to buy is 0. So it has been mentioned that once a person doesn't want to buy any more ticket, what he will do? He'll simply leave the queue. Additionally, it makes sense, right? That if you don't want to buy any tickets, so why will you stand in the line? It doesn't make any sense to stand in the line, right? So what he will do? So this particular person will come out of the queue, correct? So we will be remaining with only these 2 people at the queue, correct? Now, one more thing that I want you all to notice is, say for example, if I have 3 people, like 0th person, first person, second person, correct? If this first person buys the ticket and he still wants to buy a ticket, right? So what he will do, he'll go at the end of the queue. So it means the 0th person will come over here, correct? Now we are at the first person. Let's say that the first person has also bought a ticket and he still wants to buy a ticket. So what he will do, he'll go at the end of the queue. That is, he will come over here. Now let's come at the second person. Let's say the second person has also bought a ticket and he still wants to buy a ticket, correct? So what this person will do, this person will also come at the end of the queue, correct? Now what we notice? We notice that initially the position of this person was 0, 1, 2, correct? Now after one round of giving the tickets to each of them, what is the order of their position? The order of their position is back to the original order, correct? That is the 0th person, first person, second person. Now again, if we will assign a ticket to the 0th person and he still wants a ticket, so what he will do, he'll go at the end of the queue. So the 0th person will come over here. And again, if we will assign a ticket to the first person and if he still wants a ticket, he'll come at the end of the queue. Now if again this second person buys a ticket and he still wants to buy a ticket, he'll again come at the end of the queue. And we can see that the order is again the same, that is 0, 1, 2. So we noticed one thing, that once each of the person buys a ticket and still if they wants to buy a ticket, what we have to do? We have to simply iterate again starting from the 0th index. Why are we starting again from the 0th index? Because we found it out that once all these person buys a ticket, then the new order which we get is the same as the original order, that is the 0, 1, 2. And if they buys the ticket again, it is again same as the original order, correct? Now coming back to the question, now you might ask, what is this value k? So this value k represents the position of a person. Since k is 2, it represents the position of the second person. So where is the second index? Here is the second index, correct? So according to the problem statement, we have to find out that what is the time needed for the kth person. So what is k in this case? K is 2. So what is the time needed for this person standing at the second index in order to buy all the tickets, correct? So we can see that the person at the second index wants to buy 2 tickets. So we need to find out that how many time will be required by this person in order to buy all of the 2 tickets, correct? So initially time would be 0, correct? And we would be present at the person at the 0th index, okay? Now, how many tickets does this person wants to buy? This person wants to buy 2 tickets, but how many tickets he can buy? He can buy only 1 ticket at a time, correct? And how much time it takes to buy 1 ticket? It takes 1 second to buy 1 ticket, correct? So how many tickets will this 0th person buy? He will buy only 1 ticket. So if he will buy 1 ticket, he will be left with 1 more ticket to buy. And since he bought 1 ticket, it will take him a time of 1 second in order to buy it, correct? And what we will do, we'll move to the another person. So we are at the first index. How many tickets does this person wants to buy? This person wants to buy 3 tickets. But how many tickets he can buy? He can buy only 1 ticket. So how many tickets he will be left with? He will be left with 2 more tickets to buy. And since this person has bought a ticket, so it will cost him 1 second of time in order to buy it, correct? Now we will move to the next person. So we are at the second index. How many tickets does this person wants to buy? This person wants to buy 2 tickets, but he can buy only 1 ticket. So we will let him to buy 1 ticket and he will be remaining with 1 more ticket to buy. And it will cost him a time of 1 second in order to buy that particular 1 ticket, correct? Then we will move forward. So we are present at the third person, correct? Now, how many tickets does this person wants to buy? This person wants to buy 4 tickets, but he can buy only 1 ticket. So he will be left with 3 more tickets to buy. And it will cost him 1 second in order to buy 1 ticket, correct? Now we will move to the fourth person. Now, how many tickets does this person wants to buy? This person wants to buy 6 tickets, but he can buy only 1 ticket. So we will let him buy 1 ticket and he will be left with 5 more tickets to buy. And it will cost him a time of 1 second in order to buy 1 ticket, correct? Now we'll move forward. So we are present at the fifth index. Now, how many tickets does this person wants to buy? This person wants to buy only 1 ticket, correct? So we will let him buy the 1 ticket. So how much time it will take? It will take a time of 1 and he'll be remaining with 0 tickets to buy, correct? Now, you'll see that we have reached at the end of the array. Now what should we do? So we discussed previously that if we have 0%, 1%, 2%, let's consider 3% at a time, correct? If 0% has bought a ticket and he still wants to buy, where he will go? He'll come over here. If first person has bought the ticket and he still wants to buy a ticket, where he'll go? He'll come over here. If the second person has already bought the ticket and he still wants to buy a ticket, where he'll go? He'll come over here. So we can see that once we have completely iterated over the entire array, then what is the new order we are getting? We are getting the same order, right? That is the 0, 1, 2. So once we will reach at the end, what we will do, we'll place this ith pointer back to the 0th index, correct? So it means that it will point back to the person standing at the 0th index. So we'll come over here. Now let's see how many tickets does this person wants to buy. So this person wants to buy 1 ticket. So what we will do, we'll let him buy this 1 ticket. So he will be remaining with 0 ticket to buy. And it will cost him a time of 1 second in order to buy this 1 ticket, correct? And we'll move forward. Now we are present at this person and this person wants to buy 2 tickets. But he can buy only 1 ticket. So we'll let him buy 1 ticket and he'll be remaining with 1 more ticket to buy. And it will cost him 1 second in order to buy this particular 1 ticket, correct? Now we'll move to the another person. So we are at the second person. Now the second person wants to buy only 1 ticket. So we will let him buy this 1 ticket. So he will be remaining with 0 tickets to buy, correct? And it will cost him 1 second of time in order to buy 1 ticket, correct? Now, before moving forward, what we can see? We can see that the number of tickets that the second person wants to buy has become 0. So what does it imply? It implies that the second person has bought all of his tickets. And what we wanted to find? We wanted to find that how many time is required in order for the second person to buy all of his tickets, correct? So since at this very moment, the second person has bought all the tickets, so what would be our answer? Our answer would be nothing but this, correct? So what is this? It's 1, 2, 3, 4, 5, 6, 7, 8, 9. So our answer would be 9. That is, at the end of this 9 seconds, this second person was able to buy all of his tickets, correct? Because what we can see that the second person was able to buy all his tickets, right? So there is no sense in order to process the tickets request for all the other people as well, correct? Because we want to find that how much time is required by the kth person to buy all the tickets, correct? So we know that the moment this value of tickets at the kth person becomes 0, we will return the time. And the time over here is 9, correct? Now, talking about the approach we will be following, so we will follow the same approach. That is, we will iterate over this tickets array, and what we will do is, we will keep assigning one ticket to each person if they want to buy a ticket. Now, what do I mean by if they want to buy a ticket? Let's say if we have a person standing at the 0th index who doesn't want to buy any ticket, right? Whose ticket count that they want to buy is 0. So if this person doesn't want to buy any ticket, so we won't let him to buy any ticket, right? Because it has been mentioned in the problem statement that if a person doesn't wants to buy a ticket, he has to leave the queue, correct? So whenever we'll find that the ticket count at any particular index is 0, what we will do? We'll simply ignore it and move forward, correct? So what we have to do is, if a person wants to buy a ticket, what we will do? We will let him buy a ticket. And since he has bought a ticket, it will cost him a time of 1. And what we will do? We'll move to the next person, correct? And we will see that if the next person also wants to buy a ticket, we will let him buy one ticket and we'll add a time of 1, correct? And while doing so, we have to also make a check that is the value of the kth index 0. Because the moment we'll find that the value at the kth index is 0, then what does it mean? It means that the kth person was able to buy all the tickets. And the moment the kth person was able to buy all the tickets, what we have to do? We have to return the time, right, at that particular moment. So if the value at kth index becomes 0, we'll return time, correct? And one more thing to notice is that the moment our ith pointer will reach at the end of the array, what we have to do? We have to place it back at the front, correct? Why? Because we found out that this ordered is the one which is preserved, correct? Because we will be getting the same order again and again each time, correct? So I hope this is clear to you all. So let's quickly code this. So initially, we'll take a variable time, which would be initially 0. Now, in what are we doing in this time? In this time, we will use it to calculate the total time required in order for the kth person to buy all the tickets, correct? Now we will need another variable. Let's call it as index. We are using it in order to iterate over the given array, right? In order to iterate over this tickets array. Now we'll say that while this index is less than tickets dot size, what we have to do? We will first check that if the tickets of index is not 0. Why? It's because that if a person wants to buy a ticket, then only we'll give him the opportunity to buy a ticket, right? Because if a value at any particular index becomes 0, then what does it mean? It means that that person doesn't want to buy a ticket. So since that person doesn't want to buy a ticket, so we'll simply ignore him, correct? So we will first check that the count of ticket wanted by the person at the index position is not 0. If it is not 0, what we will do? We'll let him buy one ticket. So if he'll buy one ticket, it will take 1 second of time in order to buy that ticket, correct? And since this person has bought a ticket, so what we will do? We will decrement the count of ticket by 1 because he has bought a ticket, correct? So we will say tickets of index minus minus. Now what we have to check? We have to check if the tickets of kth person is 0 or not. So if we will find out at any point of time that the value present at the kth index has become 0, then what does it mean? It means that the kth person doesn't want to buy any more ticket. So it simply means that the kth person was able to buy all of his tickets. So what do we have to do? At that very moment, we have to return the time, correct? So we will return time. Otherwise, what we will do? Otherwise, we'll simply increment the index. That is, we'll move to the next person. And what we have to check is, we will check that if the value of this index will become equal to tickets.size, then at that time, what we have to do? At that time, we have to set this index back to the 0th index, correct? Because we discussed that we'll be following the same order again and again, right? So the moment that this will reach at the end of the array, we have to set it back to the 0th index, correct? And what we will be returning from here? We'll return time, okay? So let's quickly run this. So it's giving us the correct answer. Let's submit it. And it got accepted. Now talking about the time complexity and space complexity. So if we consider n as the size of the given array, then the total time complexity is order of n into tickets of k. Now let's see how we are getting this. So let's say we have an array of size 2. Okay. And the value present over this index is 5. And what we want to do is we want to know that the person standing at the first index, how much time does he takes in order to buy all of his 5 tickets, correct? So what we will do? Initially, we will iterate over the 0th index and we will give him whatever tickets he wants to buy, or if he doesn't want to buy any ticket, we will ignore it, correct? So let's assume that there is any arbitrary value present over at the 0th index, correct? So what we will do? We will iterate over the 0th index and then we'll iterate over the first index. And since this person wants to buy 5 tickets, we'll assign him 1 ticket and he'll be left with 4 tickets, correct? How many times we iterated? As of now, we iterated 2 times, correct? Now, again, we'll iterate over the 0th index irrespective of whether he wants to buy a ticket or he doesn't want to buy a ticket, correct? Because if he wants to buy a ticket, we'll give him a ticket to buy. And if he doesn't want to buy a ticket, we'll simply ignore it. But we have to iterate over there, correct? Now we'll come over the first index. We can see that he wants to buy 4 tickets. We'll give him 1 ticket. He'll be left with 3 tickets. So we iterated again 2 times, correct? Now, We'll again iterate over the 0th index and we'll iterate over the first index. So first index person wants to buy 3 tickets. So we'll let him buy 1 ticket. He'll be remaining with 2 tickets. So we iterated 2 times again. Now again we'll iterate over the 0th index and the first index. So we can see that the person at the first index wants to buy 2 tickets. Correct. So how many tickets will let him to buy? We'll let him buy 1 ticket and he'll be remaining with 1 ticket. Correct. So again they iterated 2 times. Fine. Now again we have to iterate 1 time over the 0th index and 1 more time over the first index. Now we can see that the person at the first index wants to buy 1 ticket. So we'll let him buy 1 ticket. He'll be remaining with the 0th ticket. So we can see that this moment the person at the tickets the person wants to buy at the 0th index has become 0. So since this became 0, so it means that the person at the first index was able to buy all of his tickets. So we will stop at this moment because we only wanted to calculate that how much time was this person taking in order to buy all of his ticket. Correct. And how much time we iterated? Again, we iterated 2 times. So we will add 2 over here. So in total, how many times are we iterating? We are iterating 1, 2, 3, 4, 5. We are iterating 5 times cross 2. Correct. That is, we are iterating twice. How many times? We are iterating twice 5 number of times. Now, what is this 2? This 2 is the length of the array. Correct. So what is this 2? This 2 is n. And what is this 5? This 5 is the value present at the kth index. That is the ticket the kth person wants to buy. So what is this 5? This 5 is ticket of k. Correct. So how much time we will take? We will take n, that is n, cross 5, that is n cross ticket of k. So that's why the time complexity is n cross tickets of k, because we have to iterate over the given array until the value present at the kth index doesn't become 0, because we want the kth person to buy all of his tickets. Correct. So that's why it's n times tickets of k. Correct. And we are not using any extra space complexity for our end. So therefore the space complexity is order of 1. Now let's see another approach that will cost us only order of n time complexity. Now let's discuss the approach 2. Okay. So initially our time is 0 and we are present over the 0th person. Correct. What we want to do is we want to find out that what is the time required in order for the second person to buy all of his tickets. Correct. That is, we want this 2 to become equal to 0. So at what time we can reduce this 2 to 0? That we have to calculate. Correct. So tell me one thing, that how many tickets will this 0th person be able to buy before this 2 turns to 0? So let's see how many tickets would he be able to buy. So if we will iterate 1 time, correct, the first time, so what will happen? This person will buy a ticket and he will be left with 1 ticket to buy. Correct. Let's ignore the person as the 1th index as of now. Fine. So if we'll see that at the first iteration, this person at the second index, he'll also buy 1 ticket and he'll be left with 1 ticket to buy. Correct. Now, if we'll do the second iteration, then what will happen? During the second iteration, we can see that this person still wants to buy a ticket. So he will buy a ticket. He'll be left with 0 tickets to buy. Correct. Similarly, the second person wants to buy a ticket. He'll buy a ticket and he'll be left with 0 ticket to buy. So how many tickets in total does the person at the 0th index bought? So the person at the 0th index bought all of his tickets. Correct. That is, he bought 2 tickets. So how much time it will take? Since he bought 2 tickets, so it will cost him 2 seconds of time in order to buy 2 tickets. Correct. Now let's see the same for the first person. So if we are present at the first person and the value at the second index is 2. Correct. Now tell me, how many tickets will the person standing at the first position be able to buy before this 2 turns to 0? So let's see. What will happen in the first iteration? In the first iteration, we can see that the person wants 3 tickets, but he'll be able to buy only 1 ticket and he'll be left with 2 more tickets to buy. Correct. Then we'll come at the second index. So we can see that the person at the second index wants 2 tickets to buy. So he'll buy 1 ticket and will be left with 1 more ticket to buy. Now we'll do the second iteration. Now in the second iteration, what will happen? We can see that this person wants to buy 2 tickets, but he'll buy only 1 ticket and he'll be left with 1 more ticket to buy. Correct. And we'll come at this person. So this person wants 1 ticket to buy. So he will buy 1 ticket and he'll be left with 0 ticket to buy. Now we can see that the value at the second index turned 0. Correct. So tell me that how many ticket was the person at the first index able to buy? So the person at the first index was able to buy only 2 tickets. Why? We can see that he still wants to buy a ticket. Correct. How many tickets were present at the first index? At the first index, there were 3 tickets present. Correct. And if he still wants to buy 1 ticket, then what does it mean? It means that he was able to buy only 2 tickets. Correct. So if he was able to buy 2 tickets, how much time it cost to him? It cost to him 2 seconds of time. Correct. Now tell me, how many tickets will the person present at the second index be able to buy before this 2 turns to 0? So the person at the second index will be able to buy all of his tickets. Correct. Because we want him to buy all the tickets, right? So he'll buy all the tickets. So he has total of 2 tickets to buy. So he'll buy 2 tickets and it will cost him 2 seconds of time. Correct. Now let's see, did we found a pattern over here? So all these values, that is the 0th index, first index, second index. Correct. Let me represent it with I. So all these I are less than equal to K. What is K? K is 2 in this case. Correct. So all these ith index are lesser than equal to k. So what did we found out that how many tickets was this person able to buy? This person was able to buy all the 2 tickets. That's why it cost him 2 seconds of time, correct? And how many tickets was this person able to buy? This person was able to buy 2 tickets as well. That's why we took it as 2 seconds over here, right? And this person was able to buy 2 tickets as well. So how are we getting this 2? How are we getting this value 2? So this 2 is nothing but the minimum of current value. Let me represent it as current val, comma, the value present at tickets of k, correct? Because let's see over here, what is the current value? Current value is 2. And what is the value present at the kth index? It's also 2. So what is the minimum of 2 and 2? The minimum is 2, so we are getting this 2. So if we will reach over here, what is the current value? It's 3. And what is the kth value? The kth value is 2. What is the minimum of 3 and 2? The minimum is 2, correct? And if we reach over here, what is the current value? It's 2. What is the kth value? It's 2 only. What is their minimum? Minimum would be 2 only, correct? And we noticed one thing, correct? That why this person is able to buy only 2 tickets. We found it out that since this person wants to buy 2 tickets, so this person would be able to buy the minimum of 3 and 2. And why are we taking the minimum of this 3 and 2? We are taking the minimum of this 3 and 2 because in this case, this person won't be able to buy 3 tickets anyway, right? Because before this person can buy 3 tickets, this 2 will already turn to 0, correct? That's why we are taking the minimum value of this 3 and 2. Say for example, if we had a value over here as 1, then how many tickets will this person be able to buy? This person would be able to buy only 1 ticket, right? Because after buying 1 ticket, the value of tickets that he wants to buy will turn to 0, correct? So what we will do, we'll find the minimum of the current value and the kth value. So what is the current value? Current value is 1. What is the kth value? Kth value is 2. So what would be the ticket that he would be able to buy? It would be minimum of 1 and 2. That would be 1. So he would be able to buy only 1 ticket because after buying 1 ticket, his number of ticket that he want to buy will turn to 0, correct? So that's why we will find out the minimum of current value and tickets. And we also did it by doing the iterations, right, until this 2 turns to 0, correct? So there is no way that a person who is standing before this 2 can buy tickets more than this 2, correct? So they'll either buy 2 tickets or they'll buy less than 2 tickets, correct? So that's why we are taking the minimum of current value and tickets of k, correct? Now let's see what about when the value of I is greater than k. So when I is greater than k, what we will do? So let's see over here. So if we are at the third person, let's see how many tickets will he be able to buy until this 2 turns to 0. The first iteration, what will happen? This person wants to buy 2 tickets, so we will let him buy 1 ticket. And what we will do? It will go and we will move to the third person. So the third person wants to buy 4 tickets, but he will be able to buy only 1 ticket, so he will be left with 3 tickets to buy, correct? Now we'll come back to the second person in the second iteration. So the second person wants to buy 1 ticket, correct? So how many tickets will he be able to buy? He'll be able to buy all the 1 ticket and he'll be left with only 0 tickets to buy. And since the person at the kth index has bought all the tickets, what we'll do? We'll return the time, correct? So how many tickets was the person at the third index able to buy? He was able to buy only 1 ticket, correct? Why? Because he is remaining with 3 tickets to buy. And how many tickets were present at the third index? At the third index, there were a total of 4 tickets. And out of 4 tickets, he still wants to buy 3 tickets. So how many tickets did he bought? He bought 4 minus 3, that is only 1 ticket, correct? And how are we getting this 1 ticket? This 1 ticket is nothing but the minimum of current val, comma, tickets of k minus 1, correct? Now let's see how are we getting this. So what is the current value? The current value is 4, comma, what is tickets of k? Tickets of k is 2. So what is 2 minus 1? 2 minus 1 is 1 and their minimum will give us 1, correct? And we saw that the person standing at the third position was only able to buy 1 ticket, right? And he was remaining with 3 more tickets to buy. So let's see how are we getting this. So the thing is, the moment the person who is at the second index, the number of tickets he wants to buy becomes 0. So will we move to the third person in order to serve his request to buy a ticket? The answer is no, correct? So what does it mean? It means that the person who is standing at the second index will get 1 opportunity more than the person who is standing after him, correct? Why? Because the moment his total tickets become 0, we won't go to the next persons, right, who are standing next to him in order to process their request of buying tickets, correct? So these all persons who are standing after the kth index will get 1 opportunity less. And since they are getting 1 opportunity less, that's why we are decrementing 1 from here, correct? And why are we taking the minimum of current value and tickets of k minus 1? It's because if we will process the request of this 5th person, correct? So how many tickets does he wants to buy? He wants to buy 1 ticket. So what is the current value? It's 1. And what is tickets of k minus 1? Tickets of k minus 1 would be 2 minus 1. That is 1. So what will be the minimum? Minimum will be 1 only. So it means that if this person will buy 1 ticket, its count will turn to 0, right? So he doesn't want to buy any more tickets. That's the reason why we are taking the minimum of current val and tickets of k minus 1, correct? So what did we saw? We saw that how many tickets was the third person able to buy? The third person was able to buy the minimum of current val, comma, kth val minus 1. So what is the tickets of k? Tickets of k is 2. So what is 2 minus 1? It's 1. So he was able to buy only one ticket. So how much time it will take him? It will cost him only 1 second in order to buy that one ticket, correct? Now what we will do, now we'll move to the next person. So we are at the fourth index, correct? Now let's see how many tickets will this person be able to buy. So this person will be able to buy the minimum of current val, that is 6, comma, tickets of k minus 1. What is tickets of k? Tickets of k is 2, so 2 minus 1 will be 1. So this person will also be able to buy only one ticket, so it will cost him 1 second of time, correct? Now let's see whether he is able to buy only one ticket or not, correct? So in the first iteration, what will happen? In this first iteration, this 2 will turn to 1, correct? Because this will buy one ticket. And in the first iteration, this 6 will turn to 5. Why? Because he will buy only one ticket, correct? So he will be left with 5 more tickets to buy. Now what will happen in the second iteration? In the second iteration, this 1 will turn to 0. And the moment this 1 will turn to 0, what we will do? We'll return the time, correct? So how many opportunities did the person standing at the second index got? He got 2 opportunity to buy ticket, correct? But how many opportunity did this person got? This person only got 1 opportunity to buy ticket. Why? Because the moment this becomes 0, we are not giving him any opportunity to buy the ticket, right? So he's getting 1 opportunity less, and that's why we are decrementing 1, correct? Additionally, how many tickets he was able to buy? He was able to buy only 1 ticket. How? We can see that he's left with 5 tickets to buy, and how many tickets he was having? He was having total of 6 tickets. So how many tickets he bought? He bought 6 minus 5 tickets. That is 1 only, correct? So that's the reason why we added this 1 over here, because since he bought 1 ticket, so it will cost him only 1 second, right? Now what we will do, we'll move to the next element. So how many tickets he will be able to buy? He'll be able to buy the minimum of current value, that is 1, comma, tickets of k minus 1. What is tickets of k? It's 2. So 2 minus 1 will give us 1, and he'll be able to buy 1 ticket. So since he'll be able to buy 1 ticket, it will cost him a time of 1 second. And we'll move forward. And we can see that we have processed all the values of this tickets array. So what is our answer? Our answer would be 2 plus 2, that is 4 plus 2, 6, 7, 8, 9. So we'll get 9 as the answer, correct? So let's do a quick recap. What we will do, we will iterate over this tickets array, and we will check that if the ith index is less than equal to k, then what we have to do, we have to add minimum of current val, comma, tickets of k to our time. Why? Because this represents how many tickets that particular person would be able to buy. And if that particular person would be able to buy x number of tickets, correct? Let's say the value we are getting from here is x. So if he will buy x tickets, so it will cost him x seconds, correct? So we will add this x seconds to our time, fine. And when the value of I, that is whenever this index value exceeds k, what we will do, we will find the minimum of current value, comma, tickets of k minus 1. And why are we using this minus 1 over here? Because the person who will be standing after this kth index will get 1 opportunity less than the person at the kth index to buy a ticket. Because the moment the value at the kth index becomes 0, we will return the time, correct? We will not move to the other person to process their request, correct? That's why we are subtracting 1 from over here. So I hope it is clear to you all. So let's quickly code this. So we will start on by taking a variable time, which would be initially 0. Now this time will calculate that how much time is required for the kth person to buy all his tickets, correct? Now what we will do, we will iterate over the given array tickets. So we'll say index equals to 0, index less than tickets dot size, index plus plus, correct? Now what we have to check? We have to check if this index is less than equal to k or not, correct? If this index is less than equal to k, what we will do? If it is less than equal to k, then how many tickets will that person be able to buy? That person will be able to buy the minimum of current value. What is current value? The current value is tickets of index, comma, the value present at the kth index, comma, the value present at the kth index, correct? So this is the count of the ticket that this person would be able to buy. And let's say that this person was able to buy x number of tickets. So what we will do, we will add this x number of tickets to the time, correct? Because it will cost him the same time in order to buy that ticket, right? Now else this index becomes greater than k, then how many tickets will that person be able to buy? He'll be able to buy the minimum of current value. What is the current value? Current value is tickets of index, comma, tickets of k minus 1, correct? Why are we subtracting 1? Because he'll get 1 opportunity less than the person standing at the kth index, correct? Now if this person would be able to buy x number of tickets, so how much time it will cost him? It will cost him x number of time only, right? So we will add the resultant to the time, because it will cost him the same time in order to buy the x number of tickets. So we will add it to time, fine. And lastly, what we will do, we'll simply return this time. So let's quickly run this. So we are getting the correct answer. Let's submit it. And it got accepted. Now talking about the time complexity and space complexity of this approach, if we consider n as the size of the given array, so what we are doing? We will be iterating over the entire array, correct? So it will cost us a time complexity of order of n, because what we are doing over here we are iterating over all the n entries, right, in order to calculate this time. So we will take order of n time complexity, and we are not using any extra space from our end, so it will cost us order of 1 space complexity, correct? So that's all about today's daily LeetCode challenge. Thank you.